Hi, my name is Olivier Capra, and I would have loved to travel to Eindhoven to attend my first this conference, but still, I'm happy to be here online to present to you our last paper, Have a Seat on Stage, Restoring Trust with Spectator Experience Augmentation Techniques. I hope you will like the video. When the collaboration between humans and machines happens in public, the audience can face difficulties in distinguishing the actual human contribution from the contribution of autonomous processes. In music concerts involving digital interfaces, doubts about the performer's contribution can drastically hinder the audience's interest. The disappearing of the direct physical link between actions and effects is one of the reasons of this confusion. Consequently, both artists and researchers have explored techniques to augment the experience of spectators. Three main challenges can be identified when considering the experience of spectators of digital interactions. First, improving the experience of spectators. Multiple techniques have been proposed to improve the experience of spectators. We call them SIGCHI, which stands for Spectator Experience Augmentation Techniques. Here are some related works. Bain et al. Investigated the use of pre-concert explanations to describe the interface to the audience. Visual feedback can also be used to give the audience information, like in Berthaut et al., who displayed graphical information on the musical interaction of an orchestra. The information can be displayed on stage and can be combined with mobile applications, as recently proposed by Berthaut et al. A particular kind of visual feedback is called visual augmentations, in which the feedback is aligned with the digital interface using an augmented reality display, as proposed by Berthaut et al. Although all these techniques may definitely benefit the spectators of digital performances, to our knowledge, their efficiency has not been formally compared. The next challenge is to measure the experience. To date, most contributions rely on pre- or post-performance interviews and questionnaires. We believe that a controlled contribution from the lab with refined measurement can provide complementary findings to the field studies. And finally, the last challenge is to refine the definition of the experience, to study it and improve it. As it is an elusive phenomena, we propose to decompose it in three main dimensions easier to address in experiments. The subjective experience is a component that can be addressed with questions like how much would you rate the overall performance or the virtuosity of the artist. The second component we propose is the objective comprehension. It can be addressed with questions like who from the musician or the computer is controlling that particular sound. And finally, we think it can be insightful to consider the subjective comprehension. This component is more about the confidence an observer has about the inner representation of an interaction. We address it with questions like, if the musician committed an error, would you notice it? So, to sum up, in this work we want to compare the impact of spectator experience augmentation techniques on multiple components of the experience. We choose to compare two common seats, preliminary explanations and visual augmentations. I will now quickly present to you our study and its main results. In this overview, we won't get into every methodological details of the study, and we invite you to read the paper for an extensive presentation of our protocol. 21 participants were involved in the study. Their task mainly consisted in watching videos of short electronic music performances and in answering subsequent questions. Let's have a closer look at the stimuli. The stimuli were videos of short music performances that were displayed under four conditions. In the control condition, the performance is displayed as it was shot, like in this video. In the explain condition, each performance was preceded by a demo of the instrument and each of its parameters, like in this video. This potentiometer controls the volumes of this sound. With this potentiometer, I can filter this sound. This potentiometer changes the pitch of the sound. In the visual augmentation condition, the performance was displayed with visual augmentations of the musicians' interactions. Here is a short presentation of their functioning. in order to control that the effect of the visual augmentations on the experience is not only due to the increased richness of graphical material inclusion, we added a disruptive condition in which the augmentations are not correlated to the ongoing interactions, like in this video. So the performances were displayed under 4 conditions. Explain for the preliminary explanations, VAUG for the visual augmentations, control, and VDIS for the disruptive augmentations. We measured their impact on 3 components of the experience: the subjective experience, the objective comprehension, and the subjective comprehension. The objective comprehension was assessed in tasks where the participant had to distinguish the contribution of the musician from the one of the computer. This contribution is objectively controlled thanks to 3 different configurations of the instrument used by the performer. Specifically, we configured the links between the controls of the instrument and the effects and sounds that they target. These links are called the mapping. So we designed 3 different mappings leading to 3 different levels of contribution. A completely manual mapping leading to a greater contribution of the musician. A semi-automated mapping leading to more balanced contributions, yet still greater for the musician. And a highly automated mapping leading to a greater contribution of the computer. The task was simple. Participants watched videos of short performances randomly displayed under 4 different conditions. After each video, the participant had to answer the question, who from the musician or the computer contributed the most to the performance? They also had to give their confidence in their answer. Our results show that when the performances were presented with visual augmentations, the participants largely opted for a greater contribution of the musician, and they were more confident in their answers. Interestingly, in the disruptive condition, when the visual augmentation did not correspond to the actual performance, the participants considered the computer as the most contributive. So even if objectively the contribution of the musician was greater in only 66% of the stimuli, when presented with visual augmentations, the participants had more trust in the musician's involvement. We addressed the subjective comprehension thanks to questions based on communication design issues. These design issues were presented by Berthaut in the context of user-computer interactions. They were then transposed by Fayence et al. To the perspective of spectators of interactions. In our turn, we transport them to a design evaluation perspective. We won't present these Berthaut-Fayence challenges into great details. Just note that in our study, they are related to the feeling of knowing something, rather than an objective knowledge. So in this task, participants watched videos of short performances randomly displayed under 4 different conditions. After each video, the participant had to give their level of agreement with statements from the Berthaut-Fayence challenges. For example, for the address item, the statement was, in this video, I know when the musician is interacting with the instrument and when he is not. And for the accident item, in this video, I can see if the musician or the instrument made a mistake. As you can see, here we are interested in what the participants think they could see or notice, rather than in an objective ability to measure, like the greater contribution of the previous block. These challenges allow us to evaluate the confidence participants have in their inner representation of the interactions. The results of the subjective comprehension show that when performances are presented with visual augmentations, the participants are more confident in their ability to notice parameters of the interactions. Interesting contrasts with the disruptive condition were also revealed. Feel free to read the paper for an extensive analysis of the results. Finally, a very quick result on the subjective experience. After having integrated the functioning of the visual augmentations, when they were asked to rate a performance, participants favored the one displayed with visual augmentations. In this overview, we saw that the visual augmentations had positive effect on multiple components of the experience of spectators of digital interactions. Besides, our findings lead us to advocate for a new item in the Berthaut-Fayence challenges, the association. That is the ability of a digital system to expose the respective contributions of the user and the autonomous processes. The association can be useful in the design process of digital interactions for public contexts. Finally, We hope this study can show that in-the-lab approaches can provide interesting complementary insights to in-the-wild studies. A last word to invite you to read our 2 other papers recently published. One is a study that refines the results presented today by evaluating the effect of the levels of details of the visual augmentations. The other paper proposes a taxonomy of the seeds. Thank you for your attention. We hope to see you soon in real life. Have a great day 2020.